Discovery, go and throttle up. All right, I'm back. Let's see what we got. I am bloody back. Who's ready? Who's ready for some Falcon Heavy action? If we get it. I don't know, man. It's 70% probability of violation, 30% go, which means there's a 30% chance of it launching. PMDG is about to drop the 777. Oh. Very nice. All right, so let's pick up NASA's stream right here.
Satellite captured this imagery from the Artemis 1 launch in November of 2022. Orion and the Space Launch System rocket broke through the clouds and left a hole in its wake. You see a little hole open up there? It streaked through the atmosphere, taking off there. And of course, the launch of Artemis 2, which is currently scheduled in 2025, will also be captured. That'll be captured by GOES-U after it becomes the primary satellite for GOES East. At the top of the show, we started loading the 3 first stage boosters. Next is the second stage. So let's check back in with Megan and Mick.
That's right, and in about 17 seconds, we expect SpaceX to begin loading RP-1 or rocket-grade kerosene into the rocket's second stage. And there you go. That's the call out there. So now we are loading both RP-1 and liquid oxygen into the Falcon Heavy rocket.
That is correct. We got RP-1 and liquid oxygen going into the first stage 3 boosters, and we just started RP-1 in the second stage. And
pretty much,
we see RP-1's about 50% on the 3 boosters, and liquid oxygen is roughly about 30% on the first stage. So getting ready to stow.
All right, they've started tanking the boosters and stuff. Look, that's Falcon Heavy right there. That's 220 stories. Or 220 stories, 220 feet or 22 stories, right? Oh, it's got the second stage with the shading on it. See that ring up there? That's a thermal protection system to prevent the propellants from boiling off. That means this stage is going to be on a long duration coast, which is pretty cool. But going back to that other shot, I mean, you look at this thing next to the Starship Tower, and it is tiny. It's a little boy. 220 stories. Yeah, it's the size of the tallest building in the world.
Locks that we want to start flowing up through the what we call the TE when we transport and erect the vehicle, and then call it the strong back once we're on the vehicle. We want to get those lines chilled down so that we can get that locks into the second stage. So that's a very important step to make sure that we don't break anything and keep going with loading today.
Yeah, because if you don't chill down the strong back in preparation, we could do thermal shock to the system, right?
That's correct. Yeah, we don't want to do that.
You don't want to do thermal shock ever. Now, if you pump the propellants through those lines too quickly, they'll boil too fast, and then you'll pressurize the line inadvertently, and that can lead to breaking things.
I'm joined by LSP flight design analyst Mark Hammett. Thanks for being here, Mark.
Thanks for having me.
Well, let's talk a bit about the GOES-U mission trajectory. So the G in GOES stands for geostationary. Can you explain what that means?
A geostationary orbit is a circular orbit around the equator, about 22,000, just over 22,000 miles in altitude above the Earth. What's unique about that number is, at that altitude, it takes 24 hours to complete one revolution around the Earth. What else happens 24 hours, one revolution?
Yeah.
The Earth rotates on its axis in 24 hours, or 1 day. So if you pair those two up, put the satellite above a particular location over the Earth, as the Earth rotates one revolution per day, and the satellite moves at that same rate, the satellite will remain over that location over the Earth. Stationary, geostationary. In terms of what we're going to see on launch day, we don't have the performance to take it all the way to the mission orbit. Instead, we're going to go to what we call geostationary transfer orbit, or GTO. And what that basically means is we're going to take it the majority of the way there.
Absolutely,
and what's most important for them is to have the sun in a particular location during that ascent sequence. So as they perform their design of how those all maneuvers would map out, they determined what the launch time would be to put the sun in the proper location for that ascent sequence.
So for this mission, we know that there's a long coast after the second burn of the upper stage. Can you explain why it's designed that way?
Sure. Right. This is a 3-burn mission. As you can see, the first 2 burns mapped out here. Those 2 burns occur in about 28 minutes. After that, then we do have this long coast period, as you mentioned. It's about a 4-hour coast until we get to the location of that third burn. So we're going to get out here, we're going to do this burn, and we're going to raise that low side of the orbit from about 100 miles to about 10,000 miles in altitude. At the same time, you can see here the bend in the trajectory. We're also going to lower the inclination, or that angle with respect to the equator, from 27 degrees down to 4 degrees.
Thanks so much for explaining the trajectory to us. Great to have you here.
Thanks for having me.
Since 1975, GOES satellites have provided continuous imagery and data on atmospheric conditions and solar activity, resulting in more accurate and timely weather forecasts. Here's more about the legacy of NOAA's weather satellites.
It all began back in October 1975 with the launch of NOAA's GOES-1 satellite.
We've come a long way in weather forecasting since the early balloon launching days, thanks mainly to weather satellites.
As groundbreaking as it was, it had limited capabilities and only viewed Earth about 10% of the time. By 1980, a new series of GOES satellites went into orbit. These satellites had the capability to obtain vertical profiles of temperature and moisture throughout the various layers of the atmosphere. In 1994, GOES-I was launched, and with it came significant improvements in the resolution, quantity, and continuity of GOES imagery and data, thanks to a new 3-axis method of stabilization. Once it reached orbit, it was renamed GOES-8 and gave forecasters more accurate information to pinpoint locations of storms, wildfires, and other hazards.
So, guys, if you're wondering what the geostationary operational environment satellites do, if you're wondering what these are the satellites that you get your local weather forecast from. So, like, if you're watching the weather in the morning on the news and they say, all right, here's today's weather, let's go to the satellite, it's a GOES satellite. Yeah, all the weather forecasts from the Weather Channel gets, the data gets downlinked from GOES satellites.
The current generation of geostationary satellites was launched, the GOES-R series.
GOES-R.
With this series came new advancements that included state-of-the-art instruments like the Geostationary Lightning Mapper and the Advanced Baseline Imager, or ABI. For nearly 50 years, the GOES satellites have provided a unique view of Earth. As the program advanced, so did the technology, allowing it to become the most sophisticated weather observing, environmental monitoring, and space weather monitoring satellite system that helps promote and protect the nation's security.
See that? See this big antenna, the big boom that's coming out the back? That's a magnetometer. The magnetometer is there to measure, the sun. They said they were looking at the sun too. That's what the magnetometer is detecting radiation levels in the magnetic field. Sorry, that's what it was. I forgot for a second. I gotta do this more often.
Or higher. GOES satellites help predict the severity and the path of these devastating storms.
Measures magnets. How do they work?
So the polar orbiting satellites complement the geostationary. Since the geostationary, like 24,000 miles up, while they get great pictures, it's really hard to measure what is the state of the atmosphere from that distance. So the polar orbiting are basically flying a little over 500 miles up. And when you're at that altitude, you can sense what's in the atmosphere to a lot higher resolution.
Two things people always want to know about hurricanes are how strong is it and where's it going to hit. And microwave sounders can certainly help with both of those. The ability to see through clouds becomes really important. If you've ever seen a picture of a hurricane from space, mostly what you're seeing is clouds. And you can get a better weather forecast, a better prediction of how strong the hurricane is and where it's going to hit, which direction it's going to go, if you could see through those clouds and see the structure of the atmosphere. Maybe even the ocean conditions underneath that. And so microwave sensors allow you to do that kind of thing.
You'd like that as precise as you can, so that only the people who are really going to be affected have to do something. The improved sensors that we've been flying allow a better understanding of the core of that hurricane and allow the forecasters to better predict precisely where that hurricane is going to hit.
Yeah, these satellites are pretty damn useful.
Shrink that cone of uncertainty and give a better prediction.
We hope to continue to improve the ability to do track forecasting. That's gotten so much better over the past couple of decades. Our 5-day forecast is about as accurate as our 2-day forecast was only about 20 years ago.
Wait a minute. Can I just...
So much better.
That's the Boston Convention Center. That's the BCC. What? Mark, what were you doing there? And there's clearly a Raytheon sign over there, so this is some type of... I guess it looks like a science fair to me. No, that's the Boston Convention Center. That, dude, I'm telling you, look. Look. That's this building. See? Look. See the catwalk and the glass and the supports and how it's geodesic, it's triangulated. Look. That's the same building. Wait, what the hell is he? That's cool.
Sampling the atmosphere and the ocean in and around
but...
hurricanes so that the forecasters at the National Hurricane Center can have a clearer picture of how the storm is developing and how it's moving.
So what is inside a hurricane that we need to know that we can't get from other instruments?
It's that in situ data. It's the pressures, the temperatures, the humidities, the wind speed, the wind direction, the ocean sea surface temperature. All of this data we're able to collect with our aircraft as well as some of the instruments that we have on board, and all of that is vital for the forecasters.
All right, you've got some amazing video that you shared with us flying in a hurricane. We want to play that now, and you kind of talk to us about what it's like to fly inside a hurricane with 150 mile per hour winds.
So this video is from our WP3D Orion. This is flying, that's actually flying through Hurricane Florence in 2018. And on the P3, it's kind of like being on a wooden roller coaster that's inside of an automatic car wash. So a lot of vibration, a lot of getting bounced around, wind and rain slapping against the windows.
There you are.
It can certainly be a bumpy ride, yes. Our Gulfstream 4 flies up above, around, and in front of the storm to sample the high altitude atmosphere, usually at 45,000 feet. And all of this data feeds into those forecasts that you see on TV of the spaghetti plots of all the different ways a storm can go. And the better data we can collect up in the air, the more accurate those forecasts are going to be.
Right there, are you like catching some air right there? Looks like the bottom dropped out.
Yes, absolutely. You can get lightning a lot in these storms. You can certainly get some hefty bumps. A lot of turbulence, but it's exciting work and it's important work.
And we saw the G4 here today at the shuttle landing strip.
That's right. A lot of people got to check it out. You have one more tool that that you use, and that is a drone. I didn't even realize that we have a drone that's going to come flying in. Watch how this thing flies right into the set. See this? Thank you, John. Appreciate that from Noah.
There we go. Perfect.
In there. I didn't realize that you guys had tools like this. What do you do with this?
So this is newer technology. We've been launching these out of our P3 Orion the last couple of years, and so these are able to get down to altitudes that we can't safely get to in our aircraft.
Jonathan,
When we're flying through a hurricane, we won't fly below 5,000 feet, but these can get down to as low as 30 feet off of the ocean surface into what we call the boundary layer. That's where the ocean and the atmosphere are really interacting. It's where all of that energy is really flowing up into the storm, and so this can get us high-resolution data at really low altitudes that we really can't get any other way.
How do they hold up? I mean, these are the most violent storms on Earth, and how does this guy do?
So typically these we'll drop these in the eye where it's calmer. They can work their way into the eye wall, and when they do that, they tend to just follow the wind. So they're not trying to fight against the storm, they're just going with it.
I was about to say, I mean, that's amazing that they can hang in there for that long to get back data. You're a former, well, you're still a meteorologist. Do you recall using data like this, and how would you work it into a forecast?
Oh, anytime there's a landfall hurricane coming towards the U.S., we have the hurricane hunters up 24/7. We're tracking every observation, every pass. They're seeing the real-time changes, right? There's no other way to get it.
Mm-hmm. Absolutely.
So what's the craziest hurricane hunting story you can tell us, Nick?
2 years ago, into Hurricane Ian, as it was working its way towards the coast of Florida.
Cat 5?
You stole Dorothy!
We were flying through at the point when it briefly intensified to Category 5. Wow. We were in the eye wall for what was 10 minutes. Made it into the eye. We're able to mark the center, launch a drone into the eye of the storm, work our way back out. That flight was the bumpiest I've been on in the 8 years that I've been doing this.
What about the lightning? Could you see it while you were in the eye wall?
Lots of lightning. I think there were over like 1,000 lightning strikes in the eye wall over the course of a couple of hours there. It was a night mission, so you could really see it flashing.
That's awesome.
It was very impressive.
It's been like
lightning
flying through a
flashing
strobe.
every second, being blown all around in a plane, and how did you feel?
It was certainly one of the more tense missions that we've been on, but all of our crews are highly trained. Everyone on that aircraft is focused on doing the mission, doing it well, making sure that we're gathering the data safely and that we're doing it effectively.
Nick Underwood, Hurricane Hunter with NOAA. It was great having you here.
That's
Thanks
killer,
for sharing
dude.
your
What
stories.
an awesome job.
Not as cool as a bounty hunter, but Hurricane Hunter. I mean,
That's
what's
the
bigger
vibe.
than a hurricane, right?
Yeah.
Yeah, that's great. Thank you very
What
much.
did he
JP.
say?
Appreciate it. Well, back to talking weather satellites. GOES-U is the last of a generation that began with GOES-R. The next generation of NOAA's weather satellites will be GeoXO, or Geostationary Extended Observation. Here's more.
Like GOES-R, GeoXO will continue NOAA's 5 decades of critical Earth-observing data. However, GeoXO will have new technology on board. One of the new instruments will be an infrared sounder, which will allow weather forecasters to see the atmosphere in extremely fine detail.
It really looks at very fine slices of the atmosphere across a wide area so that it builds up sort of a 3D view of what the atmosphere looks like. And forecasters can use that information to be very precise about their forecasts, where a storm is going to be, how severe a storm is going to be. They can even do predictions of what the precipitation levels are going to be.
The sounder will also help detect quickly changing wind speeds and direction, which will assist in everything from hurricane prediction to aviation forecasts.
Yep,
So a big part of the National Weather Service's mission is to forecast for aviation, for safety, and also looking at that fuel economy, looking at detecting the direction of the wind. So that capability is just going to be absolutely amazing for aviation and earlier detection and quicker detection of tropical systems when it comes to rapid intensification.
There will be 2 other new instruments on GeoXO as well. One will be an air quality instrument that will monitor and track harmful air pollutants, including wildfire smoke and volcanic gases. It will provide continuous observations and measurements of atmospheric composition, which will help improve air quality forecasts and alerts across the United States.
Cool.
Another instrument will measure ocean color, which helps detect and track threats to our lakes and ocean, such as harmful algal blooms and oil spills. Perhaps most critically, NOAA's GeoXO will also meet new needs for the data user community, including forecasters, researchers, and others who depend on receiving crucial environmental information across the Western Hemisphere.
These users are looking for advanced capabilities, and they've told us what they want to see in this next generation, which is going to start observing in the 2030s but continue into the 2050s. And with the changes on our planet and with the society's increased reliance on environmental information, it's really important to be able to serve this wider variety of needs.
Come and watch a rocket launch with Dad.
GOES-U's 7 instruments will gather data that can help forecasters in many different ways. For more on that, let's go back now to NASA's Philip Hargrove.
Thank you, Daryl. I'm joined here by Irene Parker, the Deputy Associate Administrator for Systems for NOAA's Satellite and Information Service. Thank you for being here with us.
Thank you for having me, and thank you for saying all those words in a correct order and everything.
It's a lot of words. We'll get into it. So, yeah, you're a leader in NOAA. Can you tell us what it feels like to be this close to liftoff?
I'll be honest, it is extremely exciting. This is my second GOES launch, but my third launch ever, and the excitement doesn't stop. I'm so looking forward to the Falcon Heavy and feeling the rumble. I'm just so looking forward to that.
Definitely a unique launch vehicle. And can you tell us what makes the GOES-U satellite unique relative to the other satellites in the GOES-R series?
Oh, definitely. So GOES-R series was mostly focused on weather and sun aspects, but this GOES-U has the compact coronagraph, which is an amazing instrument capability that was built by the Naval Research Lab. And what it basically does is it's going to look at the sun and it's going to be able to see a coronal mass injection. And a scientist basically explained to me what that was.
Coronal mass ejection.
Think of it as the sun burping up a whole lot of plasma, a lot of gas, and it's coming straight at you. And what this is going to do, this instrument, the C-Core, is it's going to basically be able to see that and detect that. And as it comes closer to the Earth, we'll be able to determine through the Space Weather Prediction Center at NOAA if there's going to be a geomagnetic storm. And if there's a geomagnetic storm, are we going to be able to make sure that our power grid is okay, our astronauts are okay, all those wonderful things. And this satellite is the first satellite.
James, Titan is a mix. Mostly cattle dog. Australian cattle dog. He's a worker dog. I like him. He's a good boy.
It's just opening the door for us to do more extended observations in the future Geo series for GeoXO. And in that series, we're going to go and actually do things in atmospheric composition. We're going to do things in ocean color and really push the boundaries in environmental intelligence. So this is just the beginning with GOES-U that happens to have C-Core, but our next generation of GeoXO is going to have some amazing instruments in there. But the other thing I don't want to forget that GOES-U is still doing is for weather prediction, right? It is the bread and butter for hurricane forecasts, for lightning, for fire weather, all of those things this satellite is capable of doing. So it's just going to be amazing to see this fourth bird launch.
Thank you so much. Awesome stuff today and awesome stuff ahead. Thank you so much, Irene. Back to you, Daryl.
Thank you both very much. T-minus 15 minutes and counting.
When did y'all get Titan C? So first of all, I didn't name that dog. That was his name from the shelter. Second of all, Rocket. Third of all, had to get him. Fourth of all, he's an awesome dog. He's already trained, guys. Yeah. He'll let me know. Anyway, back to Ginger.
Team of meteorologists, and I know that atmospheric scientists all over the country and the world are excited for GOES-U. I know we are. Of course, that high-res everything. We're going to look at that lightning data. We're so excited for the aerosol information. It's just going to help forecast. And of course, we cover all of the biggest disasters, the wildfires, all the way to hurricanes. GOES-U is going to be wonderful. I've been talking to space weather folks, and that coronagraph, having a dedicated peek at the sun every single day, GOES-U is going to be big. And we can't wait for this launch. So go NOAA, go NASA, and go GOES-U.
Titan, sit down.
All right, whenever there's a big launch, we have thousands of people joining us. But real quick about the Ginger Z thing. I mean, she talked about aerosol.
What orbit is this going to? It's a geostationary orbit. Geostationary operational environmental satellite.
See it even better.
All right, looking forward to that. Whenever there's a big launch, we have thousands of people visiting the Space Coast to feel and see the rocket firsthand, including a very special group that we want to show you right now. A special group. There they are, about 80 middle school students. How are they doing? Giving us a big old
this kid has a mullet. Awesome.
They're here
Kid on the bottom
as
right has
part
a
of the
mullet.
Students to Launch initiative, and they got a lot of energy. This is in partnership with NASA. These middle school students have traveled from all over the country to see today's launch, including as far north as New York and Maine, as far west as Nebraska and North Dakota, and south to Texas. Students to Launch educates and inspires students across the U.S. to understand the challenges and objectives of spaceflight missions, which can sometimes lead to careers in aerospace and astronautics. And that has to be one of the most enthusiastic groups I've ever seen at launch.
No, they were at my hotel this morning.
Oh, they were?
Very excited. Yeah, breakfast was a blast.
And so are you excited?
Oh, yeah, we're getting close. I can't believe it.
T-minus 13 minutes, just under 13 minutes and counting. There you see the rocket there. We've got a
toys.
little bit of time to take a few more social questions. So let's pop one of those up now. You've been doing a great job, Alec, answering all of those. The question is, coming from Space Gal, why the U in the GOES-U name?
On the grounds, the sequence that we name them is letters. So we've had the GOES-R series has had GOES-R, ST. Now we're at U. And so once it reaches geostationary orbit, it'll be renamed GOES-19.
It's just part of the nomenclature about how you name it on the ground and what happens to it when it goes into space.
Yeah.
And we have a few more questions to get answered here as we look and watch the Falcon Heavy on the pad there, getting ready to go from Launch Pad 39A.
It's cooking.
Yep. That's that LOX that's condensing the warm air in the atmosphere. All right, so we have Samuelo asks, how long will this spacecraft be in operation?
Okay, so the operational life is 10 years. We expect performance longer than that. It's planned for a period of on-orbit storage, and so we should have 15 years of use, but really we expect to be even a little bit longer than that as long as fuel usage goes okay.
It was.
Have we gone over? So the ground track, LoJack, we're looking at a 90-degree azimuth insertion, which gets you 27 degrees incline.
It'll save us. It could save us
this
a
stream
life,
is like 25 seconds behind. Hey, EJ, could you fast forward this for me? Sure, man. Yeah, we'll catch up. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding.
There at the limit
of
the weight of the
better,
GOES-U
Jim?
satellite, so that Falcon Heavy gives it the additional performance it needs to go up. And so with just a few more minutes left, your thoughts, Alec, as we get down, ready to count the final minutes before liftoff.
Oh man, I'm bottled up. I can't wait to see it. It represents such a legacy for the program, and we're all excited to see this come together
that door
for the
on
launch
me.
today.
All right, Alec and I are headed outside to watch the launch, and so we'll send it out to Megan and Mick for the remainder of the count and liftoff, and we'll see you again after the first.
All right, so this is double booster RTLS, expendable center core, from what I understand.
Launch. Mick and I are going where we're staying inside here, inside the Mission Director Center, inside Hangar AE at nearby Cape Canaveral Space Force Station, because this is where we continue to monitor the launch team as we march towards that T0.
We're inside of 10 minutes, guys.
PM.
I'm going to run ads. Here we go.
To internal power, that's going to take a couple of minutes, right?
Yeah, spacecraft's working their procedures, verifying the health of the spacecraft, getting everything ready. They'll then transition around T-minus 6 minutes, 5 minutes. They'll transition to internal power, finish up that procedure, disconnecting from the ground power at the pad, and getting ready for launch today.
So the last time you guys were with us, the launch team has begun loading super cold liquid oxygen into the Heavy second stage. That happened at T-minus 18 minutes. The next major fueling milestone, that's expected at T-minus 7 minutes, and that's when SpaceX will chill down the Heavy's 27 engines on the boosters to get ready for engine startup.
Yeah, just like we talked about on the strong back, the team needs to chill down those engines so that we don't provide a thermal shock to all 27 engines. A lot of power there. We heard Daryl and Alec talking about that, getting GOES-U on its way. That's a very heavy satellite, so right on the cusp of a Falcon 9, but this Falcon Heavy is going to give a lot of performance today. And we're finishing up, Megan, as we're looking at the telemetry here. RP1 on the first stage is coming to fill levels, and LOX on the first stage is almost complete, and second stage LOX is about 50%. So we're proceeding very well with full fuel loading today, and things are going good.
That's awesome. And speaking of weather, we are launching. We are launching a weather satellite, so we should talk about the launch weather. And we've been watching that in the hours leading up to our launch today. And right now,
once again, guys, don't get your hopes up exactly here. We're at T-minus 8 minutes, but it was a 30% probability to go. So we'll see what happens.
Launch Weather Officer Brian Cizik again confirming that we have found an opportunity to launch today at 5:26 p.m. Eastern Time.
Yeah, that team worked very quickly. Brian has definitely been very busy this afternoon.
It's like 60% now?
With
Nice.
Charlie Meyer, the SpaceX launch director, and Dr. Denton Gibson, the NASA launch
we've gone up to
manager.
70%
They moved our
go.
window
Sounds
10
good.
minutes, and they were able to find that sweet spot in the weather today to get things done. And we're hearing that RP1 loading is complete on one of the side boosters, and things are still progressing to completion of loading the Falcon Heavy.
In total, we are going to be loading 2.8 million pounds of propellant into the Falcon Heavy rocket that you see on Launch Pad 39A here at Kennedy Space Center.
Greetings, programs. Hey, want a beaver nugget? Want a beaver nugget? Sit.
Again, so far we've heard call-outs that RP1 loading has been completed in the center booster as well as one of the side boosters.
Oh, yeah, you like that.
We expect to hear a call out that the third and final booster will be completed for fueling of RP1.
Tango el perro.
Yep, the team's still progressing, looking at the telemetry on the launch vehicle. Things are progressing very well. The data
negative Y, fuel load complete.
And there we hear the negative Y, fuel load complete. So two side boosters and center core are complete with RP1, and they're finishing off liquid oxygen tanking into those three boosters.
I did, and it wasn't me, drummer.
Here shortly that LOX load will be complete as the spacecraft gets ready to go on internal power and continues
Are there humans inside? No, not this one.
Satellite.
XLE, this is a weather satellite.
As for the spacecraft, we are also expecting the launch vehicle right now to be transitioning to internal
Somebody give
power.
the Gendis a tier 1 sub. Thank you. No.
Again, we are launching GOES-U today, the fourth and final weather satellite in the National Oceanic and Atmospheric Administration's GOES-R series of satellites. And once operational, GOES-U will become GOES-East and provide continuous imagery and atmospheric measurements of the Western Hemisphere. It will monitor weather and environmental conditions in near real time, which is really critical for weather forecasting and severe storm tracking. T-minus 5 minutes and 10 seconds to liftoff.
No you. Does Titan get many hand bananas? Yes, he does. No gang signs. Hey, come here.
Falcon Heavy tanks are pressurizing for strong back retract.
Up.
There we hear the tanks being pressurized for retract. That strong back or transport erector as we use to transport out. The strong back will begin retracting here shortly. And what you will see at the top of the vehicle is those arms that are around the just below the payload fairing will open up. And once those open up, the strong back will then tip back slightly a few degrees, getting ready for launch this morning. And then as liftoff occurs, the strong back will fall back a little more to get out of the way as the Falcon Heavy leaves Launch Complex 39A.
Next up, NASA Launch Manager's Go, No Go poll, the final check to make sure the NASA team is ready for a launch that's expected in 5 seconds.
It's the RD on the NLM net with a final status check. LD, everything's looking
good on
our end.
What's the MPG on this big boy, Pepega?
Thank you.
300
Thumbs up
seconds.
from NASA, again, confirming that weather, right, was the big watch item, and that is not a
Rocket
constraint
MPG
to
is
launch
measured
right
in
now.
seconds.
Yep,
It's called
the team
impulse.
has looked at all the data. Things continue to progress very well. Weather looks really good out there.
NY
and
lock on countdown 1.
Dr. Gibson says things are good.
NASA is go for launch.
NASA reports go.
There we hear the final go for launch from Dr. Denton Gibson on the countdown net. And LOX load on one of the side boosters. There we hear the second call for LOX load complete on the 2 side boosters. LOX load is finishing up in the center core of the first stage booster, and then finishing up as we get down close to zero, the LOX load on second stage. So things progressing very well, Megan.
I do want to mention that Dr. Denton Gibson, this is his first launch as launch manager.
Yes, very happy to have him there. He has been doing very well as he stepped into the NLM position from his mission management position, and very happy to have him on console today as our launch manager for the GOES-U mission.
Stage 1, LOX load complete.
Cool, Forge. Wow.
And there we hear the call out for stage 1. All 3 boosters now have RP1 and LOX on board, so we are just waiting for the remaining LOX to fill into the second stage LOX tank. And Falcon Heavy will be tanked and ready for launch.
We expect them to finish fueling the second stage with liquid oxygen in about 20 seconds.
How many times has Falcon Heavy launched? Less than 10, Dieter.
With this
Stage
call out,
2, LOX load complete.
I don't know. There's been so many. I know that this is the first launch for this is the first launch for this year for Falcon Heavy. This is the 10th.
Very
there
well
you go.
To get to this point. We are so happy of everything's going, and as you can see on the screen right there, weather.
So what's the miles per gallon on this thing? 2.8 million pounds of liquid fuel and oxidizer. You don't really measure rockets in miles per gallon. Rocket efficiency is measured in seconds. All right, so burn time in seconds of propellant. It's called specific impulse. It's derived from the total impulse of the rocket and exhaust velocity from the engine. So how good can you blow up what you're shooting into the rocket engine? Like, how complete is the burn? And how fast does it go out the back? That's the easy way of putting it. It's measured in seconds. The higher the seconds, more miles per gallon. Now, Falcon 9 is using kerosene and liquid oxygen. Not the most efficient propellant around, but very energetic. Shoot out the back faster, right? But at the behest of efficiency here. But Falcon, the reason why it uses a less efficient propellant, hold on.
The Falcon Heavy's flight computer is now in control.
Okay, we are go. They switched on the auto sequencer at T-minus 1 minute. Everything is good. So why use these propellants if they're not as efficient? Sometimes you need a lot of power, and it's a lot easier to... hang on. Sometimes you need a lot of power, and it's easier to use kerosene. It's a very easy propellant to use, and you have to keep this simple. Rocket science gets very complicated very fast if you're not careful.
16th mission for NOAA.
A great partnership over the years we've had. Looking forward to this launch.
All right, here we go.
15 seconds.
Here we go.
Resub.
10.
T-minus 10.
9. 8. 7. 6. 5.
Sound suppression
4,
system should turn on.
3. 2.
Engine ignition.
1.
All right. Falcon Heavy's flying. First Falcon Heavy of 2024. 10th Falcon Heavy in total. Launching the
Liftoff
satellite.
GOES-U, NOAA's newest weather satellite,
dude, does that thing
to
cook.
monitor
Look at
the
that
Earth
thing.
and Sun in
Yeah,
high
baby.
definition.
Titan, this is your first rocket launch.
Engines look nominal.
He doesn't care. Okay. D plus 30, everything's looking good.
As you see the Falcon Heavy soaring towards the heavens. All 27 engines powerfully lifting GOES-U on its trajectory and ascent into space.
A beautiful shot as we track
nominal.
the rocket from the ground here. The rocket is now powering down for max Q. Max Q is the moment of maximum dynamic pressure on the rocket.
Nice.
Max Q expected at 1 minute
27
7
engines.
seconds.
Oh, did you see the vapor cone? Yeah, baby.
The vehicle is now supersonic.
Savage amount of power. Look at that.
Falcon Heavy is supersonic.
Traveling faster than the speed of sound.
Max Q.
So if it looks like flames are traveling up the side of the rocket, that's totally normal. What happens is the rocket is leaving a wake behind it. And that wake is leaving a lot of low pressure in between the bottom of the rocket and the bottom of the engine. So the flames look like they're traveling up the rocket because they're getting caught in that low pressure pocket.
On the Earth, that it is leaving.
Looks like it's coming up the
And
side
all
of the rocket.
27 Merlin
really
engines
cool.
providing 5.1 million pounds of thrust.
Stop looking at its undercarriage. No, I don't want to. Hey, this satellite, I'm an American taxpayer. That's an American satellite for
plus
the taxpayer.
2 minutes
I
and
paid
28
for this,
seconds, the
demon.
side boosters
I
are going to
paid
shut
be
off,
able to look up the
while the center
undercarriage.
core will continue on. Wow, what a shot there of, again,
Side
all
booster
27
RTLS, Vasya.
Merlin engines firing off. 5.1 million pounds of thrust.
Yep, baby.
The side booster cutoff will be referred to as BECO. We'll hear that call out. And then when the center core shuts off later in flight, we'll hear that called as main engine cutoff, or MECO.
Yeah, that's pretty good.
Side boosters are all boosters are performing nominally. Everything's looking good with the 27 Merlin
Should be
engines.
coming up on booster engine cutoff here in the next 5 seconds. There they are. Separation confirmed. Oh!
Side booster separation confirmed.
There we see
Yeah,
BECO
baby.
and side booster.
MVAC chill.
Side booster separation. The MVAC is being chilled down, getting ready for ignition. Once the center core.
Oh, that's pretty cool.
And there we heard the call out for boost back startup.
A lot of things happening here. So again, we have the 2 boosters that are going to be returning to the Cape here, landing at landing zones 1 and 2. These 2 boosters have 3 burns, so we're seeing a boost back burn
All
now,
vehicles are
essentially.
following nominal trajectories.
That's pretty neat.
Essentially, these boosters have flipped back and are returning on a path to the Cape here. There will be 2 more burns, a re-entry burn and then a landing burn. And these are going to provide quite a show for our folks that are here on the Space Coast, because you're going to hear those sonic booms, Mick.
Yeah, absolutely. We are looking forward to those sonic booms as the side boosters land at landing zone 1 and 2.
That's cool.
We're about 26 seconds away from main engine cutoff and the center core separating. Once the center core separates, we will then have MVAC, which is the Merlin vacuum engine for space, start up and get ready for what we call SES1, number 1. Today we have 3 burns for this mission to get GOES on its way, and this will be the first of those 3 burns.
You gotta drop the green screen.
There we hear the 2 side boosters have boost back shutdown.
And now we're going to watch
confirmed.
There's stage separation,
live
4
footage
plus,
there.
4,
There you go,
404.
Miko. Again, the
Core
core
stage not found.
booster separating from the second stage, and the MVAC engine on that second stage lighting up. You see that on the right side of your screen.
We're about 4 seconds from
EJ
fairing
did get a
deployment.
dog. Did you see him?
Fairing again is the two
All
the
vehicles
two
continue to
halves.
follow nominal trajectories. Fairing separation confirmed.
Okay,
There
got a
we
good
have
call for
confirmation the fairing
separation.
has
That's
deployed.
the boosters coming back.
The fairings are brand new fairings for the GOES mission, and they will fall back to Earth and
Center
be
core
recovered
is not getting
by
recovered,
the
no.
recovery ship Doug. But SpaceX will look to reuse those fairings on a future flight, along with the side boosters. As we
NASA
see
doesn't
there,
show
they're
their
coming back
telemetry around a space,
to
and I'm
Earth to
not
land on
happy
landing
about
zone
that.
1 and 2. Things are progressing very well here.
I don't want my green screen falling.
We are about
again.
a minute and 23 seconds from what we call the entry burn, where the plus Y and NY side boosters will fire up their engines to start slowing down the vehicle as it gets ready for landing.
Yeah, a lot to watch. Again, the left side of your screen, we are tracking
Greg Bach,
the
the
boosters
booster
that are
landing
coming
is
back
pretty
to the
rad,
Cape
dude.
here. On the right side of your screen, that is the MVAC engine on the second stage.
Why don't they just use a regular plane and fly higher? That's a good question, Grog. Well, once again, where this second stage is right now, a plane can really only do maybe 50, 60,000 feet, right? And planes only really go 550, 560 miles an hour. Not very fast. That second stage in this particular shot is 400,000 feet off the deck, and it's probably going like 1 to 2 miles a second. Yeah. Long story short, planes can't go up here, dude. They can't go up there. That would be cool. I'm sorry, buddy. I want to live in a world where we could just take off on a runway and just fly up into space. Closest thing we ever got to that was the space shuttle, but hopefully in the future we get better stuff. But yeah, planes can't go up there, Grog. That was a good question, though.
The Psyche mission.
And I'm glad you guys are enjoying the content.
The side boosters actually that we used on the Psyche mission will be used for our future mission,
get back here.
Europa Clipper, this October. So
I missed the
brand new
space shuttle,
hardware
too.
today for GOES and everything.
I'm a
looks
huge
like it's
space
performing
shuttle.
very
Space
well.
shuttle guy.
All the telemetry, everything looks
I
nominal for
celebrate
the
that
flight
vehicle's
so far
entire
today.
catalog.
Yeah, those who typically watch our launch broadcasts.
Entry burn startup.
Okay, there's the entry
There
burn.
we heard the call for entry burn startup. The vehicles are slowing.
Come on, big box it. Woohoo! Double supersonic retro propulsion right there. The 2 side boosters are coming in. And what they're doing right now is they're firing their engines to slow themselves down and avoid re-entry heating. The boosters shooting their rocket engines are actually pushing the plasma away. You can see them right there. We got a double track.
On 1 and 2.
Oh,
Beautiful.
that's good, man.
Very
That's cool. Star shot, 36
From the
months.
ground as we
PR202
track
with a
those
9-monther.
boosters, make their way
Dude,
back
look at
to
that
the Cape.
thing. Come on, baby.
We saw some birds fly
landing. Let's go. Birds?
into the camera's view as well.
Everybody wants to see the landing
Exactly.
of the side boosters. As we said earlier, Megan, the landing will be exciting
awesome.
for a lot of people to see.
Blue flare.
Getting 2 side boosters coming back to
Supersonic
landing zone 1
retropropulsion.
and 2. We
Said
will
it
get those
twice.
sonic booms.
All right, they should be
I know
firing their
that,
engines here very
you
soon.
Here in the MDC, we will get some.
EY transonic.
Boosters are transonic. Where's it going? These are coming back down
We
to
will get
land.
some loud
Satellites
shaking
going up
right
into
here in
space.
the Mission Director Center.
Come
I know
on,
a
baby.
lot of people right here in Brevard will be excited when they hear the sonic booms.
EY landing burn.
Okay, landing burn has
burns
started
just
on either
started up.
booster. Dude, look at that. Look at that.
Wow, look at that. As
No,
it
I
guides
just
its
said
way
that,
back
Megan.
down.
Jeez. Oh!
Woo! Just heard the 2 sonic booms here in the room.
EY/NY landing light deployed.
Oh, welcome to the future.
Our monitors shaking as we watch these two
that
boosters
is just
land.
Awesome to see the two side boosters choreograph their way down to landing zone 1 and 2.
EY/NY landing confirmed.
We have successful landing of the two side boosters. Everybody looks great
So good. It
on
never
the
gets
landing
old,
zone
man.
1 and 2 as MVAC continues its
I've watched
mission
all 10 of these.
with this
It never
first
gets
burn.
old.
And there we heard the call out for SECO, which is
that's
SECO
cool.
1, second stage engine cutoff for this first burn. And things look very good. The trajectory looks. We hear the call out there that nominal orbit insertion. Everything looks great on the second stage performance for this first burn, Megan.
Yeah, and what you're looking at now, everyone on your screen, is the trajectory for the second stage of the Falcon Heavy with GOES-U. So again, it's making its way across the Atlantic towards southern Africa. This was the first of 3 burns for the second stage. The second stage will now coast for about 18 minutes before reigniting for its second burn. And if you look at the bottom of your screen there, we have a progress bar full of our milestones that we're covering during this live launch broadcast. And SES-2, that is that second burn we were talking about that will happen in, again, about 18 minutes from now. So Mick, as you said, so far so good. Really exciting launch.
Very exciting launch,
good,
and
man.
we got through that weather.
He is a rescue
and
cooking,
GOES-U's on its way.
Yeah, very dramatic and appropriate weather
Absolutely.
as we and the launch team navigated that to see us lift off from the Space Coast at 5:26 p.m. Eastern Time. Again, we'll be with you for some of the milestones that you see on the bottom of your screen. But for now, let's turn it back to the host desk. Daryl and Alec, take it away.
All right, thank you very much. If you're just joining us, welcome live to the Kennedy Space Center in Florida, where we just saw GOES-U launch from right here at the Kennedy Space Center from Launch Complex 39A. I'm with Alec Krautman, who is from NOAA. I am with NASA, and this was a heck of a launch. We watched it out there together. It was interesting. I mean, that rumble and that roar. What do you think?
Oh, man, what a view. How did we get this weather window? It was outstanding. It was beautiful out there.
It was fascinating. You made the point to show me, like, look behind you. Here's these massive clouds that have accumulated behind us, far enough off to the west. But then as we looked to the east, it was totally clear. Saw the thing go up the whole way.
Yeah, it's rocking and rolling in New Orlando, but we were all good here.
I tell you, you got to love Florida. Appreciate them holding off those storms long enough to get this thing going. Well, now the satellite is surviving the rigors of riding a rocket into space now, but we've got a long way to go, Alec. There's a lot more to do. We've got another short burn and then a long coast phase before we have separation. And then a NOAA team will start commissioning the satellite. So as we jump ahead in the timeline, what else does that involve?
Yeah, so these satellites will be operated out of our NOAA Satellite Operations Facility in Suitland, Maryland. And over the next several months, they'll be, first of all, letting the satellite do outgassing for a period of time, and then calibration and validating and checking out the instruments. And then we'll see first light with the various instruments later this fall.
All right, looking forward to that, and we'll keep chugging along here on our broadcast. In 2021, people living in southeast Louisiana were hit with catastrophic damage from Hurricane Ida, but there was fair warning of what was coming, thanks in part to high advanced resolution imagery from GOES satellites. Here's a closer look.
Yeah, that double booster landing is
Ida will
winning,
long
dude.
be remembered for its destructive, deadly path that stretched from Louisiana to the northeast.
I got a dog, bro.
For meteorologists at NOAA's National Hurricane Center in Miami, NOAA's GOES-16 satellite provided the advanced high-resolution imagery for closely tracking Ida and developing accurate forecasts from start to finish.
Scary. 92-month resub, STS-92, October 2000. The 100th shuttle flight as Discovery goes to the ISS. Mission brought up the Z1 Trust segment and involved in a lot of EVA goodness. Hey, man. How you doing? That sucks. That sucks about the Glenn, dude. I'm bumming. But hey, whatever. Win some, lose some. You guys did good.
Wall of a tropical cyclone, and it can be a telltale sign that a storm is getting better organized and intensifying.
Yeah, when we started to notice the mesovortices in the eye, you know, that was during a period of time when we were starting to see some pretty dramatic inner core structural changes.
What genre of dog? He's a Australian cattle dog mostly, but a mix with a bunch of other dogs.
Drop. Both of those changes can make a hurricane's winds and storm surge more destructive and deadly.
Hey, come on back now.
But Ida still had a surprise after it made landfall. The mesovortices in its eye continued to spin around the eye, even while it was over southern Louisiana.
It's quite unusual for us to be able to see the mesovortices, say, hours after landfall. And the reason is because after a storm comes ashore, it typically loses its fuel source. It loses its the warm ocean water, and that causes the storm to weaken.
But Ida's mesovortices were still visible over land because of what scientists call the brown ocean effect.
What?
Researchers have found that some tropical cyclones can maintain their strength long after landfall, or even strengthen over land by tapping into the abundant soil moisture below it.
We think that the reason that the storm remained strong in this case was due to the presence of that marshy land. So it was almost like the hurricane didn't know it was over land. It thought it was still over the warm ocean water.
Hurricane Ida will definitely be a storm for the history books, and its full impacts are still being tallied today. For future hurricanes that threaten the U.S. and elsewhere, NOAA satellites will be our eyes.
Stay tuned for this channel. Wait, no, we don't want that. GOES is going to be the eyes in the sky.
Everything's good with the spacecraft and rockets so far. Let's check in now with NASA
Gary,
leadership.
that's awesome.
Hargrove is with NASA's Sandra Connolly.
Yes, thank you, Daryl. I'm here.
So let's think about this for a second. What would cause Ida, what causes that brown effect, dude? Think about it. What would cause that brown effect? Warm water is the fuel for the hurricane. That's what makes hurricanes bad. If they cross warm water, they get really, really powerful. So if a hurricane hits land, what would cause it to strengthen? Improper way. Did you catch the actual explanation? I didn't. The dog, dude. My guess is high humidity and a high water table will probably do it, weather guy. Also, too much fiber for the hurricane.
And so they stare over the U.S. or over the actual whole Western Hemisphere and provide us really critical data as storms are forming and
Flooded
evolving.
land is close
so
enough
that we
to
can
warm
be
ocean, high water
in advance
table,
of,
humidity
during,
in the
and
soil.
actually
There you go.
support after storms occur.
Hurricane
so it
had too
really
much,
is an
or it had too much
satellite
Chipotle,
system
whatever.
for us.
Awesome. Can you talk a little bit about this connection between
Goalie, I saw it. It was
NASA and
dope.
NOAA and how that has developed
Thanks for
over
the great
years?
launch coverage. Got a jet, but definitely we'll be back.
So we have had a partnership for 50 years with NOAA. We have been building these kind of spacecraft. We develop them, we launch them, we commission them, and then NOAA operates them. And it's to support both terrestrial and space weather. Space weather is basically the sun's sending energetic particles towards, well, it's throughout the solar system, but it's when it comes towards the Earth that it can sometimes impact our power grids and cause problems for us here on Earth. So it's important to study space weather as much as it is
Hey,
awesome. And can you tell us about what's next in this NASA-NOAA collaboration?
Yeah, so again, we've had a long-term partnership, so we continue to plan for the future. So there is a GeoXO series that is going to be the GOES R series follow-on. So we're very excited to be partnering with NOAA on that. But also NASA has, on the space weather side, we have a mission called IMAP that's launching in the springtime. And we have a rideshare mission called Space Weather Follow-On, which is a NOAA mission. So we're going to be advancing our work in space weather as much as terrestrial weather.
Awesome. Very exciting stuff. Thank you so much for being here. Glad you got to witness that in person. And thank you again.
Thank you. It's fabulous.
All right, I'll send it back to you all.
Thank you. And we've been talking, of course, about GOES-U and the mission as we continue to track the rocket and spacecraft there, T+17.
So right now the second stage is in a coast period. It's going to do a coast period it's coasting in a parking orbit right now, guys. So the velocity is probably about, 27,000 kilometers and change here. It's going to go around till it gets to the apogee, right? And the apogee was established during the parking orbit, and what it's going to basically do is do a positive second burn here. That's what SES-2 is. So it's basically going to accelerate. It's going to turn on the engine facing the direction that it's going, and what it's going to do is increase the apogee of the orbit from where it is up to 23,500 miles, or about 38,000 kilometers that way. That is the height that you need to reach a 24-hour orbital period. What is orbital period? Time it takes to do one revolution. These weather satellites have an orbit that's 24 hours. So at a certain altitude with a certain orbital period, it'll appear to hover over Earth. It'll hover over whatever slot it was inserted to. No, okay, all right. Okay, how geostationary satellites are kind of mapped out is correlative to longitude here. So if you have a GOES satellite that's not 180, that would be like 70 west, right? It's 70 west longitude. That's how the slots are determined for mapping. Okay. He was sleeping and you woke him up. Someone buy a new flag for KSC. What? Nice.
To 7.
Hey, WD-40, how about that double landing, dude?
Forecast for this hurricane season, very important to the folks.
Goes east to 72.5 degrees west and goes west is 137.2 west. There you go.
This year.
That's right. We're really seeing exceptionally warm sea surface temperatures across the Atlantic Basin, the Caribbean, and the Gulf, and that's the main driver. We're also seeing weaker wind shear aloft. That would be a favorable environment for these storms to take off.
Right, and so when it comes to planning, it's really important that people have a plan. I think it's probably, every year we hear it, start a plan now. Most people, I think, or many people, I should say, probably say, I'll worry about that when I hear that's a storm coming.
I think, an active season forecast is a helpful reminder to revisit your plans every year, right? It really just takes one storm to impact your community, and so it could even be a light season, and if you get hit by a hurricane, then it's a big one for you, right? We had one of our Hurricane Hunter aircraft with us at Kennedy earlier today.
Titan is my dog's name.
With our satellite imagery from GOES, the Hurricane Hunter aircraft, we're ready at NOAA for hurricane season, so we encourage everyone along the coast to do the same.
Alex been doing a great job answering my questions and showing off the instruments of GOES, but also throughout the show, we've been asking you to submit your questions on #AskNASA from the social media. So
I couldn't name a Apollo Hokie. That's what I named my Roomba. And before you ask, my other Roomba is named Artemis. Yeah, I have 2 Roombas, one for first and second floor of my house. All right? Apollo and Artemis. Duh.
This will be this GeoXO series.
What prompted looking for a dog? Time. I would like to add that I did not name this dog. This dog was named Titan from the MSPCA. That was the name that a shelter gave him, I think, in Tennessee or something.
New instruments, a hyperspectral sounder, an ocean color instrument, an atmospheric composition instrument, and that'll give us more information about our environment and our climate.
All right, another question. Let's go to Avincia.
Sputnik is a good
she
name.
Asks, why are the satellites renamed? Why are the satellites renamed once they reach orbit?
That's right. So on the ground, we go by the letters. So this one was GOES U. Once it reaches geostationary orbit, it'll be renamed GOES 19. It's indicative of the successful mission once it makes it. This is a risky process, and so it gets a new name once it achieves that milestone. And then we have the operational GOES East and GOES West positions.
Actually, Titan is short for Titan 3C. The C meaning Centaur. Titan 3 Centaur. Oh, buddy, I'm sorry.
By the director of NOAA.
Guys, I'm going to go take him for a walk. I'll be right back.
Observations, El Sayed Talat. Thank you so much for being here.
I'm very pleased to be here. Very excited.
Awesome. Yeah. How was the launch? Tell me what your experience was like.
It was fantastic. It was picture perfect. It was beautiful. And the sound was just amazing.
Yeah, really, really was. So we've heard a bit about this compact coronagraph. Can you tell us a bit more about that instrument and why it's important that that's on GOES-U?
So the compact coronagraph, or CCOR 1, is the first operational coronagraph that we're ever going to fly in space. And it's a advanced solar telescope that blocks the disk of the sun so that we can measure the outer atmosphere of the sun, the solar corona. And it's very important to measure that because that's where space weather, extreme space weather events originate. These large explosions off the sun called coronal mass ejections that can send billions of tons of matter hurtling towards Earth at millions of miles per hour.
Right, so it kind of creates its own solar eclipse. I think that's what you told me earlier.
Yes,
right?
Basically this telescope will be able to take a solar eclipse and send it down to the forecasters every 30 minutes, within 30 minutes, so sooner than that. And it'll be the continuous operations of having a solar eclipse basically within 30 minutes continuously.
And can you tell me about how this instrument works with the other instruments on board?
So what this instrument does, it allows us what our long-term forecasting in space weather. So 1 to 4 days after we see an explosion off the sun, we measure the characteristics of these explosions and put it into our models that propagate it towards Earth and see if it's going to come towards Earth, and then estimate how big the impact is going to be. And we really need to know that because that's important to protecting our technological infrastructures. These solar storms can affect the power grids, civil aviation, and other satellite operations, as well as communications and navigations. And this works in tandem with the other solar instruments on board that measure the solar and EUV, X-ray and EUV irradiance and image the sun. And then the imagery of the sun gives us the context imagery of the sun that is basically like looking at the Atlantic basin for tropical cyclones as they develop, and then they might develop into hurricanes. We look at the sun with the solar ultraviolet imager to see if these regions of activity, which are centered around sunspots, if they're going to develop and produce flares and explosions, these coronal mass ejections. And we measure those effects with the irradiance measurements and the particle instruments that we have on the GOES satellites.
Very interesting. And then what's next for NOAA in, with regards to space weather prediction?
So it's a very exciting time for space weather because we're developing, enhancing our capabilities. We are going to fly next year, in 2025, the Space Weather Follow-on L1 mission that is going to be an upstream buoy for measuring the solar wind and incoming solar effects 1 million miles upstream of Earth towards the sun.
Very exciting stuff. Thank you so much for being here, and I'll toss it back to you, Megan.
Philip, Meg and I, again, are back here at the Mission Director Center at Hangar AE on Cape Canaveral Space Force Station, and we continue to monitor the teams as they continue the journey to deliver GOES-U to its correct orbit around the Earth.
Yeah, things are going very well. That first burn, all the telemetry looked very good. Nominal, the vehicle's in a coast phase right now. Our next step coming up will be SES-2, that second burn, which we should be hearing here in about 20-25 seconds. Things are progressing well, and GOES-U looks very good.
Mm-hmm. Again, the milestone bar at the bottom of your screen is where we are in the milestones to getting GOES-U into its correct orbit. SES-2 is that second burn that we're talking about, and we're tracking that for 26 minutes and 19 seconds. So 5 seconds from now.
Yeah, he's a worker, dog. All right, they're beginning chilled. They're chilling down the second stage here. See all that ice that's coming off there?
All right, and there we go. We see the MVAC engine on the Falcon Heavy second stage lighting up. This is the second of 3 burns for this engine.
It's going to be a little...
This burn is going to last about 1 minute and 27 seconds.
Yeah, it's going to be a longer burn. That's what I was going to say.
Things are going very well with the launch vehicle.
So, I don't know if you guys could tell. That nozzle's kind of warm. Kind of warm. Funny thing is, the way that... Ooh, a little bit of nozzle oscillations there. That's okay. The way that... Well, that was probably not the best time to give that explanation. But anyway, the reason why the nozzle glows is actually because that's how it sheds heat. Because you can't convect heat in a vacuum because it's a vacuum. There's nothing to absorb heat. So how does an engine, a rocket engine, which gets pretty dang hot, work up there? Well, that particular engine is made out of a very interesting metal composition. It's niobium. Yeah, I think that's what it's called. And the glow right there, the glow right there is actually how it cools itself. It can't do it via convection. Definitely can't do it via conduction. Conduction means something is touching it to absorb the heat. I'm pretty sure licking that would probably not be a good idea, right? Pretty sure. Wouldn't want to do that. So what does that leave? That leaves radiation. The light, the emissive light that happens, so the nozzle glowing is actually how it's bleeding off heat. So the engine doesn't melt. Very interesting. Do geostages end up in a graveyard orbit? Yes, Dead Scum, they do. Yeah, miss you. Would have been nice to have some data here. Where are you? Oh, good boy. How long would it stay hot? It actually sheds that heat off really quick. If we could see it at engine, when you saw an engine shut down, it goes away pretty fast. There you go, Chief. There you go. Yeah, it's a little late over there. Yes, anesthesis. Yeah, we had dogs growing up, or a dog growing up. I had a boxer, so I know work dogs. I know, like, that's why, you know, I went and took him for a walk. Work dogs need to go outside. They have tons of energy. You got to bleed off that energy. So I went outside and ran back and forth up and down my yard a couple times, and I came back in. I love boxers. Yeah, me too, man. Me too. All right, so second stage engine start isn't for another 4 hours, guys. Degs? You like Degs? Rip center core. Center core is long gone, Elsers. Long gone. Hi, did I just miss a Falcon Heavy launch? Yeah. Thank you for streaming. Hey, no problem. Yeah, we want to see it again. Here.
2, 1.
That's nice.
Go you.
Liftoff of GOES U, NOAA's newest weather satellite, to monitor the Earth and Sun in high definition.
Oh, baby.
Engines look nominal.
Dude, that thing is righteous.
It's looking good, as you see.
Look at that rocket. That's 5 million pounds of thrust. That's 2/3 of a Saturn V thrust. Yes, any unit but the metric system. Okay, this is America. Just kidding. So 5 million pounds of thrust. Saturn V made 7.5 million pounds of thrust. That's 2/3 the thrust of the Saturn V in itself, and that's not even close to SpaceX's most powerful rocket. Starship Super Heavy at liftoff is 15 million pounds of thrust. It's double the thrust of the Saturn V.
The vehicle is now supersonic.
Falcon Heavy is supersonic.
Traveling faster than the speed of sound.
Yeah, Dead Scum. I know. He gets very thirsty very fast.
There, we heard the call for max Q, maximum dynamic pressure on the Falcon Heavy. Vehicle still performs very well. All data looks nominal.
Yeah, it's pretty impressive looking, isn't it? How about the Saturn 1B?
On the Earth,
the Saturn 1B, I think, is 2 million. It has 8 H1 engines. I forget how much power those engines make.
Coming up at T plus 2 minutes and 28 seconds, the side boosters will shut off, while the center core will continue
Here,
on.
we'll get to the good stuff. You guys want to see the goods? Watch this.
1 and 2, we will get those.
Watch that. Oh man, is that cool?
We will
Stage 2 FTS is saved.
We will get some loud shaking right here in the Mission Director Center. I know a lot of people right here in Brevard will be excited when they hear the
1.6. There you go. Oh, man.
Landing burns has started up.
Terminal guidance.
Dude.
Wow, look at that.
Dude.
As it guides its way back down.
Dude.
Woo! Just heard the 2 sonic booms here in the room.
PYNY landing light deploy.
Our monitors shaking as we watch
amazing.
these two
that
boosters
is just
land.
Awesome to see the two side boosters choreograph their way down to landing zone 1 and 2.
PYNY landing confirmed.
We have 6.
You ever take a day to just watch historic rocket launches and talk about them? I could. Dean, yeah, I could. Sure.
Successful landing of the two side boosters. Everybody looks great on the landing zone 1 and 2 as MVAC continues its mission.
So yeah, all right, guys, that's a good replay, and that's gonna do it for Goes U. Goes U is on its way. Now that Falcon 9 second stage is gonna do another burn, but that other burn's gonna be 4 hours away. So what I've been doing in the meantime, the game that I've been playing is well, car parts. See? Car parts. We have that rear end to put in that Camaro. So I am going to jet out there for a moment. Cap hats. Mechanic simulator. Yes. Oh, nice pictures, goalie. Very good. Titan is jonesing to go outside. You're just jonesing to go outside, huh? Okay, fine. Fine. Oh, that's from the ocean. Oh, wow. Hold on. Real quick. You guys aren't going to want to see this. I'm not 100% sure whose footage this is, but it is awesome footage. This is from Cape Tour's boat here. Check this out.
Oh, that's cool.
Sonic booms. Damn, that's cool. That's awesome footage. I really hope we can get some credit for that footage wherever it's coming from. I don't know who's is. Go to 258. What's up? What do you want? Where am I going with this footage? 258.53. This is from a Mecum auction. Oh no! Oh no! Thanks, Gumbo. Where are you going? Titan's down there. Hey, buddy. Oh, remember, if you ever own one of these trucks, don't push the hood down. Push the hood forward. Push it towards the glass. You try to pull it down, it's going to do that. That sucks. What year is that? It's a 1980? Actually, no, that grill isn't right for 1980. That's like a late, well, that grill 72 to, actually, yeah, that might be right. Hey. Well, that's a good way to lose a lot of money. Those square body hoods are worth. That sucks. Anyway, that's going to do it for Falcon Heavy. Thanks for the stream. Yeah, and we will get back to wrenching in the shop. I'll just keep us on science and tech. What we're about to do is very technical schmechnical. So I hope you enjoyed. Goes you. That was good stuff. All right. You know how much money you just lost? Yeah. 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 All right. Stand by for lots of signal from here, from the office as expected. What are you doing, doggo? What are you doing? What is he doing? Titan, what are you doing, pal? Just a curious dog. Hey, buddy. Want to go outside? Yeah, you want to go outside. He wants to go outside. What Harbor Freight welder do you suggest for a roll pan? If you want to just go buy a flex core, go do it. But if you know something about welding and you want your welds to not suck, I'd suggest go getting a MIG welder. Hobart's will do it though. Yeah. Anyway, let's go out into the shop. Bree is grilling out there. Hopefully she's not burning the chicken. Look at all that smoke. All right. We're going to go out in the shop. Stand by for lost signal from the office as expected. Right. Do we have a schmacquisition of schmigmal? Do we have an acquisition of schmegma? I mean signal? Yeah, no, maybe? Man, is it hot in here. This place roasts like a freaking oven. I need a heat pump in here badly. Badly. Audio is nominal. Good, good, good.
Dog.
Good, good.
Where Mama going? Where Mama going? It's okay. No, come on. It's okay.
Ernok, do you have Facebook?
Yeah.
Do you have MySpace? I was gonna say, put this up on Facebook Marketplace. Put this rear end on Facebook Marketplace.
Think about it. I think about it.
I think about it. One last removal. Okay, we got to pop this and we got to get the shocks out.
It's all right. She just went inside. Come on, buddy.
Titan, you looking for your mom? Where's your mama? Where's mama? Hey, boy, how you doing? Bree was cooking chicken, guys, so.
No. No, gotta stay. You can go over there.
Jeez, this dog. This dog, he really likes to
No,
go everywhere.
There you go.
Can we have Titan audio? Why do you want an audio of the dog?
Hey, buddy. Gotta stay here.
Yeah, he's just exploring.
No, gotta stay here.
All right. So guys, we're just gonna grab a quick snack and then we'll get back to work. We need a cam on Titan. Oh, jeez.
Oh, you'll be okay. Come see Dad. Come on. Go see Dad.
Hey, come here, pal. Good boy.
Come on. Come back this way. There you go.
He's a good boy.
Who's a good boy? Yeah, you are. Yes, you are.
Look at this doggo.
Yes, you are. You're a good boy.
All right, we're gonna get back to work here in a second. We gotta get the dog out of the shop. Because if I leave him in here, he's gonna end up getting into like some transmission fluid or oil or something and start drinking it.
Come on, bud. You want to go back to the house? Yeah, you go back to the house.
Unplug your mic if you're going down to the house. Cool. Okay. This thing. We have to start putting components on this. I actually got to get my phone. All right. I got the telefono. And we will get back to work in here momentarily. Chicken legs, if you're still out there, I see you in the YouTube chat. Yeah, I got my blinker fluid ready, man. Got my blinker fluid ready.
Chicken.
Good?
Good chicken.
You don't eat chicken. I guess it's quick snack time here. Yummy. And move over. Move over. All right, let me get my phone. Yeah, foodage. Yum food, please. I'm gonna take the mic off here for this real fast so you guys don't need to hear us chewing. But yeah, we'll be here, but we'll be just a little bit quiet. Again. Good. I want cocoa. I gotta go poopy.
That's so funny.
Chicken is great, babe. Very tasty. You men eat your dinner, eat your pork and beans. I eat more chicken than any man ever seen. Yeah, yeah. Benny, you didn't know. Apparently, Boeing started the F-15 production back up. Yeah, the F-15EX. Chopsticks are getting ready to hug 14.1. Oh. Yeah. No cold beer? It's down in the house.
It's hot. Water's not advanced.
Hey, Predominant. It's going good, man. How are you? We're just eating chicken. Then this has got to go in there. It's a light. More like post-recessive. Got him. Almost done with the chicken. Can we start?
This will be interesting. The dip's got to go back in. We got to start breaking in the door.
Breaking into what?
Put the some of the parts onto that dip before we lift it into place.
part should we put on? What part should we put on the diff? I'm saying it so they can hear it. So the lower control arms. They're trailing arms. Yeah, yeah. Okay. What else?
Back bar.
The sway bar?
Yeah. No, not the sway bar.
Panhard bar.
Panhard.
Yeah.
The sway bar can wait until we get the different lengths. We need to take a look at the coilovers and see what's involved in actually putting those in place.
Yep. Because we don't need shock tower perches anymore.
And get the brake lines behind.
Brake lines? E-brake?
Yeah, get the e-brake maybe line.
Yep. This chicken's really good. Bree did a good job.
Oh wait, did I finish mine before you?
I'm looking at the cap, bro. Think we should paint this? We could paint it, I suppose. Or we could just put it in. It's crazy to me that this diff is, it's got more scale on it than that. That still has the factory paint on it.
I was doing some looking up since we can't find the axle code. And if it's a 342, that would be from 83, 84, no, 82, 83, or 84. Those are the ones we found.
As you can see, it is fuzzy. See that? Both wheels turning in the same direction when you go to move it. All right.
I'll take the plates now.
Okay.
We want to start getting paperwork out, figure out what we need to do for the suspension bits.
Remember to change the game. I left it on science and technology on purpose, man.